Thank you for this opportunity. I'd like to express what an honor it is to be here today to share with you some of the developments at NVIDIA. I want to start by thanking the organizers, Mayabi-san, Nishi-san, Abe-san, Kudo-san were very helpful in my preparation for this. And what I'm going to share with you in the talk are some of the developments and directions we plan to go with a program that we call Earth-2, which will be a digital twin of the Earth. And I'll wait for the slides to display. Am I controlling the slides? There we go. And I'm representing work from a number of scientists based in the headquarters. We're in Santa Clara, California in the USA. Not a great place at the moment for climate science, given the current government view on things. It's a very sad condition. So it's really nice to be in a place where climate change matters and to hear people express that in the presentations that we've seen today. So I'm going to share with you some of the work and just start with a brief introduction about what this is about, what Earth-2, how it was established, why it was established, what it means to the community, and how we will move this forward. Just to start though, Earth system science became a domain of focus for NVIDIA in 2011. I was at the company at that time. We started to work on development of numerical physical models with GPU computing. That work is still ongoing. I'm going to show you some list of projects we have currently investing in. And then in 2018, that's really when the AI machine learning focus started. And that really became driven by the community. We had early collaborations with important organizations like ECMWF, NOAA, NASA, et cetera. And in 2018, there was the first full emulation of an AI weather model. That was a paper published by ECMWF scientists Dubin and Bauer. It's seminal work, but it wasn't the scale that we see today, and I'm going to talk a little bit about that here in a moment. And then in 2019, NOAA established the first international workshop on leveraging AI. NVIDIA was a participation in that, and things really went to the races after that. So in 2021 rather, Earth-2 was introduced by the NVIDIA CEO, Jensen Huang. He personally helped develop this program I'm going to describe. And in February 2022, we published the first full-scale model that we call ForecastNet, and I'll show you a little bit about the history on that. And then a rapid progression of models quickly followed that. And today, the Earth-2 program is roughly 50 FTE, which means full-time equivalents across the company, 5 different organizations involved. And we work closely with partners like NOAA, ECMWF, et cetera, because it's, again, a community-driven program. But I want to mention here, this is very important, that our mission is not to become a weather forecasting or climate prediction organization. We depend on partners like Weather News for that. We're providing frameworks and demonstrations of our technology and provide that in ways that can be deployed by industry. And again, we're community-driven, and you'll hear more of that as I go forward here. And I mentioned the physical models. We have collaborations with these organizations currently, and collaboration in this case means we apply 1/3 or 1/2 of an engineer scientist time to work with these particular numerical models that you see here. This is the current focus we have in our investment. Now, there's another set of projects ongoing that we may or may not directly invest in, but we do provide guidance. There's 2 important ones here in Japan, the NICAM model. I saw my colleague, Dr. Yashiro, who's here, who is representing that work at the NIS organization. Aori, Dr. Sato is here, Professor Sato from University of Tokyo. Very important development. We plan to get more involved. You might have heard about Fugaku Next. It's going to be a large GPU system in Japan, and these kinds of numerical models will be important in that. ASCA, which is the short-range regional model from JMA, the dynamics, we know about some work going on there. We plan to invest there too. Now, these are a list of projects that could become those that we invest in that I showed on the previous page, and so we watch all these very closely. But let's turn now to Earth-2 and what that's about. It's a platform with 3 components, basically, taking the data from these physical models or Earth observation data, providing that to these AI models we've developed to then develop data-driven surrogate models and then use a back-end visualization system we call Omniverse to help convert that into digital twins. We work with a number of different models. I want to mention this is not just a focus on NVIDIA developed models. All models and methods run on GPUs. We're friendly to all. So you'll see Google, Microsoft, other models in this environment. They're available for any scientist to work with in our platform. And Earth-2 was developed during COVID. You'll see the timing here. And again, our CEO spent a lot of time looking at lectures during COVID. We all had our own activities during that period, but he spent time, and we gave him pointers on certain lectures he'd ask about where numerical models were kind of falling short on the HPC scale and needing some kind of an approach that would be AI-driven. And that's really what motivated Earth-2 and why he launched the program. And most of these scientists are based in Europe, where I think most of the climate weather leadership is ongoing. But there were a few very important, and I encourage you to look at these yourself if you're unfamiliar with some of the work here. Now, to give you a quick timeline on the models and program milestones, I mentioned, you'll see the very first milestone were these lectures. That was something the CEO sat through again. In November 21, he announced the program. Then in January 22, he asked that we form a science advisory committee. Again, very important because this is community driven. And these were scientists from the ECMWF, Max Planck Institute, Barcelona Supercomputing Center, NASA, Swiss Supercomputing Center. These are unfunded, unpaid advisors to help us keep our direction and focus towards community driven. Very important. And then everything you see in green, the first model, ForecastNet, was published in March 22, but everything you see in green are global or regional models we've developed under this program. I'm going to share with you some of the details of these as we go forward. And the first was the ForecastNet that was published in 22, and that was an important milestone because it was the first time a fully high-res model was emulated. I mentioned the Dubin-Bauer paper in 2018, and this gives you a sense of the scale and how it went in the publication of these full-scale emulation models. And NVIDIA was the first, and really our goal was just to show what could be done with the technology. It wasn't to develop the best model. We don't have the best model. We don't have the best skill, but to show what's possible. Because at the time, no one had the scale of GPUs NVIDIA did, so we were able to go and do this and demonstrate to the community it was possible. Very important work, and you can see that the resolution in this work from emulating full model increased some 500x in 4 years. Very remarkable progress for this community. Now, at the same time, you had Huawei and Google. You might be familiar with Pengu Weather, GraphCast. These were all developed around the same time. We were all doing demonstrations because we had GPUs available to do such. And Google came up with the GraphCast, GNN-based, had far more variables, and became a really popular model. Again, running on GPUs, we're friendly to all these. And you can see now today at several of the global operational weather centers, and here I list ECMWF, which is European-based, NOAA in the US, Canada, Germany, Korea has an operational model now, and the CMA in China. They're more or less based on variations of GNN or Google GraphCast, which has been popular again, different approaches. I can share more with you during the break about the specific implementations of their technology. But you'll see that NVIDIA has been involved in some of these. At the KMA, for example, we have a nowcasting model based on some NVIDIA technology. And we've been in evaluations of all these. ECMWF, NOAA, everyone evaluated NVIDIA technology as they went through this. So very important work that's now resulted in operational weather models. Now, what was interesting, too, is that an organization like ECMWF, which is the leader in weather prediction, everyone agrees with that, their R2O is actually 3 months. If you go back and look at the published work, 3 months. A typical R2O or research operations at NOAA is still on the order of 2 years, could be more, for a numerical model. So this is remarkable progress that was made in implementing these. And one thing about these AI models is they don't require the kinds of HPC resources you see with numerical models. So you don't need a new implementation of hardware in order to launch these in operations. NOAA has moved forward with their 3 models that I mentioned. One in particular that's important is they've had a breakthrough in the hybrid ensemble-based system they call HGEFS, which is based on a hybrid of 31 members in their ensemble from the numerical model and 31 members from the AI model. Very important work. They invested in a large GPU system to drive this forward. And then I'm going to talk a little bit about the latest development with ForecastNet, which was a massive ensemble development that we now have published. And it's important because it shows what can be done with HPC, where you're not restricted to 100 members of your forecast like you would see in a typical numerical scenario. Here you can run thousands, 10,000 members. The HPC cost is practically zero. I say there's some cost, but nothing like the numerical model. And you can start to understand some of these low likelihood, high impact events like you see here in this heat wave example. And we've had industry deploy this technology now. Again, this is where our partners take the technology forward. We show demonstrations and templates of how it's done. This insurance company based in Europe, AXA, has run ensembles in the thousands to understand hurricane tracking and implementation of disaster risk. And we've also launched 3 new models. I'm going to talk about those a little here at the AMS if you attended that in 2026. One of those has been really important in the regional scale modeling. I'm going to get into the details of that. Because next I wanted to address the theme of the conference. I was asked about that and how NVIDIA would develop technology around that. You know, the theme of with the increasing level of disasters, what are the front lines of implementation for early warning systems? And we've had some activity in this area. I'm going to talk a little bit about the actions of where we are now and then a proposal of what we could provide there. But the actions have to do with NVIDIA's involvement in programs like the AI NPP, which is a WIPS program under WMO, if you're familiar with it. It stands for AI Nowcasting Pilot Project. It's being funded at some level. It's not operationally, but it's going very well. And most of our involvement with that has been direct collaboration with the KMA, the Korean Meteorological Agency. And I'll share a little bit about that. But the proposal really is to see how we can take certain model technology, and I've identified 3 of those models. We've got now probably 12 total, and how we could work with a partner like Weather News to help implement these in regions where they make sense and in applications where they could really help. And these models are the CorrDiff, Storm Scope, and Sea Model. I'll get into the details of what those are here in a second. Now, the WMO, if you follow their view on AI and the directions they're going, they formed this task team they call the AI for WX back in 2024. You can see the members there. You might recognize many of those, at least the organizations they represent. And that's been an organization who's identified all the activities and tried to understand directions WMO may go, where they might invest to help drive AI into the forecasting procedures. AI NPP was one of those programs. Like I said, it's a WIPS program now. It's funded. And NVIDIA has been involved in this from the beginning. It was introduced first at the Congress in 2019 under the Early Warnings for All session that WMO hosted. You can find more about that. And they've structured in a way that are looking at 3 regions, and we're involved in the Asian Pacific region in particular, again, through our collaboration with KMA. But you'll see, too, that there's other commercial organizations involved. Microsoft, I think Google's probably part, they're part of this. So it's really an effort by many of us to help drive this in society, the benefit of society. It's not a commercial activity that we're, at least in our involvement. And the 3 models, again, that I mentioned, the CorrDiff, Storm Scope, and Sea Model would all have applications here. I'll start quickly with what we're doing on the CorrDiff model, which is a downscaling model that we apply. There we saw an opportunity to take a global model prediction, such as what you can get with an ERA 5 emulation at 25 kilometers, and then downscale that for regional understanding of, in this case, an example working with the CWA in Taiwan of how to understand better the local conditions of typhoon. And I have here just a very quick demonstration of that, where we have a 2-kilometer nest, if you will, which is a two-step downscaling to 8 kilometer, then 2 kilometer, to help get better resolution of what was a 25 kilometer based simulation from the ERA-5 ForecastNet data. And there's other industry deployments of this technology, CorrDiff. In the UAE, an organization, G42, who develops large HPC systems, has deployed this in an end-to-end weather-based system where they've got the global model providing boundary conditions to the weather system, complete end-to-end, where CorrDiff is at the core of this in their end-to-end pipeline. And this work is presented on our website if you'd like to find more detail. We've now taken the CorrDiff model and extended it to a very large scale, the US continental. And you can see I've overlaid here the area of Taiwan and UAE. And this was a scale of HPC that was beyond what's typical for numerical models to train this CorrDiff over this region. And we continue to do these kinds of demonstrations to show what might be possible in your region and can help you understand if you were interested to apply this in that way. But very high resolution based on 3 kilometer over the continental US. And you can see here some of the results from that. I didn't want to get into a lot of scientific skill comparisons, but just to give you an idea of how the solution can compare to the ground truth that you see demonstrated here. It's not animating, but I'll be happy to share this with you if you'd like to review those. All right, so let's review some of the developments of StormScope. It's a new model just introduced in January 26 at the AMS, and it's a model that's really based on AI nowcasting and nearcasting targeted for extreme weather and severe weather precipitation. And it's really 2 models in one. It's got a nowcasting model from 0 to 2 hours that's based on a DOP technology, if you're familiar with that, direct from observations to predictions, where it can read in satellite observation data, radar data, et cetera, and produce a forecast directly from that. But we also have opportunity to provide data from other model sources, if you will, to look at longer, say, nearcasting from 0 to 12 hours. It's been a model very popular based on diffusion transformer technology, a new architecture that's been introduced, uses satellite observations plus the radar I mentioned, and has been pre-trained on the CONUS in the US through 8 channels of the GOES satellite data. But there's other opportunities to demonstrate how it could work with other data that's available. And then recently it was featured at the NOAA NSSL, this National Severe Storm Lab in US, at their HWT, the Hazardous Weather Test Bed. I would encourage you to go and read this report. I've got the link there that gives you some indication of how these various models did in the spring experiment, which is something NOAA does annually with this, to sort of test the verification of these models in severe weather scenarios. The results aren't published yet, but we've seen some very good results of what was possible with this model, the StormScope. All right, and the final model I'll talk about is the C model. Before I get into that, though, I wanted to just address that these models are all based on reanalysis data at 25 kilometer. But what's the next step? You know, this is moving fast. We have to get higher resolution from these models. And there's a lot of investigations in the community towards that. At the supercomputing conference in 2025 in November, the award for the most important achievement went to this organization driven by ULIC, Max Planck Institute, others, to develop a full kilometer scale resolution of the Earth system. This was not just an atmosphere model, it was a full component coupled model to get this level. It's just an enormous amount of resource that's applied here. And this kind of work is only possible with the scale of a system like the Jupiter, which is the largest system currently in Europe, with some 28,000 GPUs. And some of the themes around this and how it can be applied now for AI modeling will be explored in this KM scale workshop that's coming next month. I know Professor Sato is here. He's one of the key organizers of this, and NVIDIA will participate at this where it starts to investigate how can we make use of these kilometer scale simulations, because you're not going to get many of these. The amount of resource that you apply to this, it's questionable whether you've caused more harm to the environment just from the amount of power consumption and carbon footprint. Okay, so there's a number of efforts all around the world towards developing models at global scale. A very important one here in Japan, in NICAM, driven by Professor Sato, Dr. Yashiro is here, and others, to help develop, even in this case, 220 meters, so going sub-kilometer. But you'll see around the world, Europe is leading most of this. There are 3 modeling efforts in the US, but everyone's trying to get to that level of kilometer scale where we can then use the data from those models to train AI surrogates and really benefit from the resolution that can come from these increases. We're involved in most of these projects you see here in helping to develop them on GPUs, which is very important to achieve the scale that I showed earlier. And there's a number of HPC systems around the world supporting these efforts. There's 4 here in Japan. Some of those aren't deployed yet. The Fugaku Next at Riken will be one of those, based again on NVIDIA GPUs, but currently NVIDIA's 13 of the 19 systems around the world that support these kilometer scale efforts, and more continue. And what's coming out of these, and this is just one example, is other challenges we weren't necessarily prepared for, like the data size that comes from these models and how to effectively use that in these models in order to get the higher resolution into your AI surrogate. I won't get into the details, but you're talking about petabytes of data that you now have to work with. And this is one of the themes that will be explored at this KM Scale workshop next month also. Very important area of focus right now, and NVIDIA is involved in that. In fact, we've worked with a few organizations I'll show you here in a moment. But some of these organizations are starting to look at how can we actually make use of these kilometer scale models. ECMWF, again, who leads weather prediction worldwide, just did a very simple calculation to understand what would be possible to deploy this in an operational weather environment, right? This is not climate, but weather. And they saw that their file sizes and data storage would increase a factor of 40x, going from the current 9-kilometer operational model to 1 kilometer. Just really impractical with the kind of technology we have in place today. So again, these are the kind of themes that are going to be investigated. And then Professor Sato had explored some of this too with his simulation of the global LES 220 meter on the Fugaku system, and found that a third of the time was spent in I/O, right? These are challenges we may not have been prepared for. Now, this is work he presented back in 2022 at the PanGas conference. There's a more recent paper that you can find on work that was presented that I was able to locate that's also referenced at the bottom here. So very important developments in how we can manage the scale of this data that's coming from these kilometer scale models. NVIDIA's had some experience. We've been working with various projects. NextGEMS is one of the projects I showed on the global efforts around the world. We're working with the ICON model data. They were the ones who did the kilometer scale full Earth system model. We're working with 5-kilometer scale data. It's been a challenge. We haven't gotten to the 1 kilometer yet. We still have many questions about how we're going to get there. But we worked with the 5-kilometer data, working with an organization in the US, the Weather Company, who produces daily forecasts in a commercial environment. With the impasse model, we've worked with data there that's a variable resolution of 4-kilometer to 15-kilometer over ocean. And then lately, an organization in the US, MITRE, on taking the HER system, which was 3-kilometer, and increasing the resolution to 1 kilometer. So we've developed this Weather 1K data set, it's called, based on running the HER, which is based on WRF, at 1 kilometer of what was 3-kilometer. Really just enormous amounts of resources needed to develop these simulations and understand the requirements there. And 2 of the organizations I just listed, MITRE and the weather company are taking this further at a commercial level and trying to figure out how they could develop models based on this. So they're now working with that Weather 1K data set, understand new applications that haven't existed yet. You know, if you look at what's been published, there's not a lot of work yet on things like wildfire or air quality. These are new areas and applications that are possible now when you get to a kilometer scale that weren't possible with looking at a global reanalysis data, for example. And then the climate in a bottle is probably the most important model we have in development for looking at these kinds of problems, because it does manage at some level this data scale that I mentioned. It was featured in numerous articles, and it's really a model that helps you to simulate global climate, kilometer scale data, that resolution, but in a climate services interactive sense. Okay, and I'm going to give you a little bit of introduction to that, but not a lot of detail. But it's a model, again, that was trained on the 5-kilometer ICON data that I mentioned earlier from the Next GEMS program, along with the AR5 reanalysis data at 25 kilometer. So you've got a combination of the reanalysis along with kilometer scale data. And what it can do is help provide a sort of compression, in this case 3000x, to help that data produce climate services like interactive response to different scenarios that one might have in mind for applications. And this is based on a fully interactive system that gives you the response not at the scale that you've brought into the model, but something that's reasonable and provides these what-if climate scenarios. And I've got a few examples here, not to go into detail about them, but to show you what's possible in some of the realistic skill that can come from these in various scenarios. It's a foundation model, I should have mentioned, and can work with a number of applications depending on users' interest. And I'm going to give you one example of work that we did prior to some interactions with IMD and the Ministry of Earth Sciences in India, where we took just some simple examples. Again, we do demonstrations and templates and so on. And in the sea bottle prompt, we asked to show several realizations of a potential Indian monsoon onset given current average surface conditions, and give the output in precipitation and wind maps. And you can see the region we worked with. It's a global foundation model again, but you can choose a region in the world you'd like to work with and develop these kinds of climate scenarios. Developing a sort of climate services approach to the use of the model from kilometer scale data. All right, so there's a number of notable trends that we also have. There's driving directions that we're going. I just want to mention a few of those briefly. Certainly, we're seeing a lot more focus on the operational models. That's going to continue. A rapid move to the DOP approach that we've seen. There's a number of organizations involved in it, not just NVIDIA, but the direct from observation and prediction. A lot of people believe that's the next step we're going to see in weather prediction. Hybrid physics, AI, an area where it's important to preserve a lot of the physics in these models to make sure that we're staying true to the numerical model consistency. And models with longer lead times, where we're now starting to couple different components, not just look at atmosphere, but couple ocean to that and other Earth system components for a full model. And I would encourage you to also look at some of the programs being led in Europe currently that I think are driving a lot of the directions and the community focus that I mentioned earlier. Anemoy framework is one. Destination Earth, that was one of the lectures I mentioned on the first introduction. And then this weather generator, very interesting project that's going to develop the first foundation model for full-scale weather that we're involved in from the ECMWF. I've got other references I'm not going to go through that you can see when you get a copy of this presentation. And just wanted to thank you again for this opportunity. And I'm here for the full day and able to answer any questions about things I went through too quickly. Thank you again for the opportunity.